Endless runner, or even random level generator is the topic of this video. There's different ways you can make it work, and it depends what type of game you're creating. For one of the ways, I already did tutorial videos on it when I was creating Keep the Tractor tutorial series, and in that one I was randomly spawning obstacles. So if that's the game type that you're looking for, be sure to check that out. But in this video I'm going to be looking at another approach, and it's by using parts. If you used Buildbox before, parts is just like a scene or a level in Buildbox. So what I mean by a part is basically a pre-made section of your game. And then in your game, you can use those sections to create your endless runner, which is how this demo right here is running. I'll start by explaining how it works so that you get a good understanding of the whole process. And then I'll demonstrate how you can create this system using both visual scripting, and I'll finish off the video with showing how you can create this using C#. Currently, I have the C# version running, and if you take a look in the hierarchy, you can see that there are parts that are being created and removed. And to see that process in the game, let's actually decrease the draw distance. So let's set to something like 12. And now you can see that when the ball gets closer to the end of the last platform, a new one gets drawn. If you make the value large enough, then you can't see when the next part gets created. So that's the part drawn distance. The other one that I have here is the part delete distance. And you can't see them being deleted, but if I switch it to something like 9, you can see that the parts get removed behind the ball. Again, if we increase it big enough, you'll no longer see those parts being removed. We can go to the scene and focus on the player, and we can see how that is working. So the ball is traveling and new parts get added in front and the parts in the back get removed. Now let's click pause and check out how the parts are connected. So right here I have a part, and that part has a start point, you can see right here, and an end point. And the next part is connected at the endpoint of the previous part. So that is how the connection is being made. So let me show you quickly how you can create the part. Like I mentioned, the only thing the parts need to have for it to work with the script that I'm about to show you is a start point and an end point. So if I remove those, this is basically a section of the game. So you can add obstacles there and whatever you want here, but at some point you need to add those start and end points. Now those start and end points, there's nothing special about them. So you can create a new game object, call it start point, and you can position it at the start of your part. For my part, this is going to be the start. You can put the exact value if you want, so 0.5, and the Z needs to go to 0. That's the start point. Now you don't have to actually have that green label there. That's just my preference, so I can visually see where the start point is. To create that, you can go right here on this icon and you can select any of these colors for your label. I went with green for start point, and you do the same thing for the end point, and we'll select a red one for this one. Now I called my game object start point and end point because that's what I'm going to be using in my script to search for these two game objects. So if you want to change these names, be sure to change it also in the script as well. So let's position that at 0.5 and 0. And that's it. That's the only two things that you need to add to your part or section for it to work with the script that I'm going to be showing you. You could actually use just one point, for instance, the end point, and remove the start point. But for that to work, you need to make some rules for how you create your part. So if you want to have just an end point, and you don't want the start point, you have to always start your part from 0, 0. So you have to move your part so that the 0, 0 point is in here. And in the script, I'll actually mention where you can modify to use this approach instead. But I went with actually 2 points. I think it's visually easier to see, and for me, it's actually easier to set up as well. So that's a little bit about the parts. Now let's go take a look at the variables that we're going to be using in the scripts. Now in the script, I also provide a list of parts here. I have 3 parts, one that is straight, one that is going up, and one that is going down. So just basic parts. In these parts, you can also add obstacles, and you can make the part as long as you want. You just need to move the end and start points to the right positions. And if I create new parts, I can always add them into this list of parts. And that's the list which I use to randomly select what part will be added next. let's actually look at the other variables as well. So this is the next part position. And I also use the value of this one to determine where the first part starts. So -11 in the X is where the first part is going to be drawn. Then I also have connection to player so that I can calculate the distance from the player to the part. And that's all the variables that are used in the script. Now, the same exact variables are used in Bolt visual scripting. So let's go and take a look at the visual script setup. I'll turn off this game object, turn the parts visual script. And right here under variables, you can see the same exact variables. So I have a list of game objects for parts. Then I have next part position, a -11. Then I have a player, part draw distance 30, and part delete distance. I'll change it to 15. So that's the same exact variables that we saw for the script. And I use the same variables for visual scripting. In here, I have two script machines. I'm using Unity 2021. So it's now called script machine instead of flow machine, but it's the same thing. One of them I called part loader, so it's responsible for loading those parts. And the other one is called part remover, which is responsible for removing parts. I broke them down in visual scripting so that the graphs would look cleaner. And let's start by looking at the part loader. So let's add a graph. So the first thing that we need to know is if we want to draw a new part or not. To determine that, we need to check the distance between player position and the next part position. So the variable next part position is actually a vector 3. So that's the value that we're going to use. And then we can use get position to get the position of the player. Now you could have used a vector 3 distance node to determine the distance between those two positions. But if you use distance, you might get into issues when the player jumps too high and the distance in the Y direction is larger than the distance that you're looking for in the X direction. So instead of doing that, I decided to just go and use subtract and check the distance between just the X. Because my game is going in the X direction, I used X here. But if your game is moving in the Z direction or in the Y direction, you can replace this get X with the direction where your game is moving. So that's one thing to keep in mind. After I get the distance between the X position, then I check if it's less than the part draw distance. If it is, that means that I need to draw a new part. Now the value of the check goes into a while loop. And the reason why I'm using a while loop is because when the game starts, I don't have any parts. So to be able to create all the necessary parts to start the game, I have a while loop. So it just goes through and creates as many parts as it needs at once. At the body output, I connect it to create new part graph. And in this graph, the first thing that I need is to get a random list item. I created a super unit for this, so it'd be a little bit cleaner. And inside this super unit, all it is doing is getting a list, counting the items, and getting a random range from 0 to the count of items. And then using that random range value for getting the item and passing it out. So just a simple random list item selection. As the input to this unit, I pass the list of parts, which we configured in the inspector. So here are the 3 parts. Once I get that random item, it's time to instantiate it. So for instantiating, I pass the original game object here. And next, I need to calculate the position. Now for the position, because I actually decided to use start point in my setup for parts, I have to do this extra calculations of shifting the next part position by the start point so that the connection would be made correctly. So because of that, that's the whole offset thing here that I had to create. Otherwise, you could have just used the next part position as the position. It would have made it much cleaner, but that's a decision that I made for my system. For rotation, I get my rotation from the prefab. And for parent, I use this game object to parent it to, which was called self in the previous version of Bolt. After I instantiate the new part, what I need to do is shift the next part position to the new position, and it's the endpoint of the part that I just instantiated. So I get the new instantiate game object, find the endpoint of that part, get the position, and set it to the next part position. And that is it. That is how a new part gets created when it needs to be created. So let me go here, and for now, let's turn off the part remove script so that we run part loader script only. Click play, and now we should be able to see that our parts are being created. And if we go to scene, You can see that those parts are being created, but they are not removed. So that's why I created the second script, the part remove. So let's enable that one. And you can see that it goes through and removes all of those parts that are outside of our part delete distance. Let's take a look at that script now. So here is the script. The first thing that I do here is check to make sure that this game object has at least one child. Because I parented all of the parts into this game object, I can now check those child game objects to find out if I need to remove it or not. So if there is at least one child, then this if unit, which was called branch in the previous Bolt versions, it will run the next graph. It gets the first child in the game object, and the first child, since I haven't rearranged the children in this game object, will be the earliest part that we created. Because in Unity, when a new instance gets created, it gets added from the bottom. So knowing that, we can treat the first child of this game object as the first part in our scene. After I get the child, I do the same distance comparison between player and this part. So I use a subtraction, and I also look at the X value only, because my game is moving in the X axis. So if your game is moving in another axis, just make sure you change this to the axis that your game is actually moving. Compared to the part delete distance, so if that value is greater than the delete distance, that means that we move far enough for us to remove this part. So if that is true, again, I have an if here, but in the previous Bolt versions, it was branch. If that was true, all I do is destroy that part. Now, I don't have any object pooling or any of that set up in this demo, but if you want object pooling, you can expand on this setup here and add object pooling to it. Those are the two graphs that are creating this system. Basically, once you have those graphs set up, you can use these configurations right here, the part draw distance and part delete distance, to change when you want to delete them and when you want to draw them. Use the next part position to define where your first part is going to be drawn, and then also provide all the parts that you want to use for your game. Now, if you want your parts to be loaded in a specific order, you can do that by modifying this part, get random list item. So instead of using this super unit, you want to create a way to load a part at a time. This is the place where you would do that. Just a side note. Now a quick run. So everything is working fine, and we can see that it's working like expected. Okay, we can turn off that, and now we can take a look at the C#. So we already went through the variables. So let's go and take a look at the script itself. The script is really short. So right here at the top, I define those variables that are used in the inspector. Then on start, I load parts because I want to load the initial parts for the game. And after that, on every update, I run the remove part script, and then I run the load part script. So that's the start and update methods. Now right here, I have the load parts method, and in here I have a while loop that checks for the distance between the next part position and the player transform position. I'm getting the X distance here because my game is moving in the X axis. If your game is moving in another axis, make sure to change this to the axis that your game is moving. So right here, I compare it to the part draw distance, and in the while loop, I get a random part from the parts list. Then I use the part to instantiate the new game object. So pass in part as the original, and then use the next part position shifted by the start point position. For rotation, I use part rotation, and for parent, I use transform, which makes this game object the parent of the new part. After I instantiate new part, then I set next part position by finding the endpoint of the new part. So that's the method for loading a part. And right here, I have the method for removing the part. So right here at the top, I check to make sure that this game object actually has children. So if there is a children, then I continue with the logic of getting the first child of this game object. And that will be the first part in the scene. So that's the part that I would check if I need to remove it or not. I calculate the distance or the difference between the player and the part position. And then I use that vector 3 and also get only the X value of that difference to compare it with the part delete distance. If you're using another axis in your game than X axis to move your player, make sure you change this X to the axis that you're using. So you need to change it here for the load part, and also you need to change it here for the remove part. So if it's larger than the delete distance, then I just destroyed that part. And that is it. That's all the code for the part controller script. And here it is at work. So in this video, I showed how to create a visual script and a C# script, how to create this endless runner system. If you want a downloadable of those scripts, I'll provide it on my Patreon. Thanks for watching. Be sure to click on that like button. And if you haven't subscribed to the channel yet, subscribe, and I'll see you later.